This video is on coordinate geometry. We're going to be looking at quadrilaterals. So we have a parallelogram. The area formula for a parallelogram is area equals base times height. The properties of a parallelogram state that opposite sides, so top and bottom or left and right, are congruent. So we have the top and bottom are congruent and the left and right are congruent. We also know that opposite sides will be parallel. I'm using the symbols for congruent and parallel. So the shape will look something like this. So we have the top and bottom are congruent. We have the left and the right congruent. So I'm using the tick marks for that. We also can show that they're parallel. So I'll use the parallel symbols, the little arrows on the left and the right, and the top and the bottom. So I use two arrows on the top and the bottom to show that they are not parallel to the left and the right. So on the coordinate plane, how we'll see this is that opposite sides, to show they're congruent and parallel, opposite sides have the same distance and the same slope. So we have to find both distance formula and slope to show that it is a parallelogram. The next shape is a rectangle. The area formula for a rectangle, area is equal to, again, base times height, or some people might see it as area equals length times width. Same as a parallelogram because it has some of the same properties. Now, the properties of a rectangle is that opposite sides, so the top and bottom and the left and the right, are congruent and parallel. So opposite sides are congruent and parallel, just like a parallelogram, but we have connecting sides. So the top and the right, or the top and the left. So connecting sides are perpendicular. A rectangle has the top and bottom are congruent. The left and right are congruent, but not to each other. They are parallel. So the top and bottom are parallel. The left and right are parallel. But we have the connecting sides are perpendicular, meaning we have right angles. Perpendicular are right angles on all four of the angles. So to show this on a coordinate plane, we'll have opposite sides have the same distance and the same slope. But we also have to show that connecting sides, which are called adjacent sides, have opposite reciprocal slopes. So we have to use slope and distance. So once we find the slopes of all the sides, we can then compare the top side with the right side, and then the right with the bottom, and then the bottom with the left, and then the left with the top. We can compare all those because we'll already have all the slopes. For a rhombus, the equation for area of a rhombus is area equals 1/2 times d sub 1 times d sub 2. Both of these d sub 1 and d sub 2 stands for the diagonal. D is the diagonal. So from the corner point to another corner point. I'll show that in just a moment. But it's the first diagonal times the second diagonal, and then half of that. So for a rhombus, it states that all sides, not just opposite sides, but all sides are congruent. But opposite sides are still parallel. So this shape is almost like a square, but it's not a square because we don't know if it's right angles or not. It's a square turned on its side. It's almost like it is a parallelogram, but all the sides are congruent. So a diagonal, when I was talking about diagonal here, a diagonal goes from angle to angle. This is the diagonal is what I'm talking about. And then the other diagonal goes from corner to corner. Those are the diagonals. So to show the properties here, all sides are congruent, so I'm going to have one tick mark on all of the sides, because all the sides are congruent. But we do have to show the parallel. So the top is parallel to the bottom, and the right is parallel to the left. But we do not have right angles. So to show this in a coordinate plane, we'll have all sides have the same distance. But we'll have to do that opposite sides, not all sides, but opposite sides, have the same slope. So again, we'll find the distance and the slope. A square, the area for a square is equal to base times height, or we might see area is still equal to length times width, or you might think of it as area is equal to side squared, because all the sides are the same. So for a square, we have all sides are congruent, just like in a rhombus. A rhombus is a square tilted. All sides are congruent. Opposite sides are going to be parallel. But the big thing about, so we're going to have opposite sides, opposite sides are parallel. But because it's a square, we're going to have connecting sides are perpendicular, just like in a rectangle. So we're going to have a square. We are going to have the all sides are congruent, so all of them will have one tick mark on them. We'll have the opposite sides are parallel, so the same thing as a rhombus. But the difference is now they have a right angle because they are perpendicular on all of the angles. So again, to show this in the coordinate plane, we're going to show that all sides have the same distance, that opposite sides have the same slope, just like in a rhombus. But just like in a rectangle, we need to show that connecting sides, so the top and the right, have opposite reciprocal slopes. because we want to show right angles. So again, once we get all the slopes, we can then compare the top slope to the right slope to the bottom slope to the left slope to the top, to show that they all have opposite reciprocal slopes, to show that it is a square. The next quadrilateral is a kite. The area formula for a kite is just like that of a rhombus. The area is equal to 1/2 times diagonal sub 1 times diagonal 2, which again, D stands for the diagonal. So for a kite, the properties of a kite is that we have two sets of adjacent, so connecting, adjacent sides are congruent. And that's all we have. Now for a kite, you might have seen a kite before that looks like this. The diagonal here that we're talking about is from corner to corner and then corner to corner. Those are the two diagonals it's talking about. So we would need to know the length of the longest diagonal times the shorter diagonal. So to show the two sets of adjacent sides, so the connecting sides, we have 4 sides here. We have 2 that are connecting. We have the top left connecting to the bottom left and also to the top right. So this side would be congruent to the top right. The 2 tops are congruent and the 2 bottoms are congruent. Now, if they're sideways, then you'd have to look at the 2 smaller sides would be congruent and the 2 longer sides would be congruent. You have to actually show that with the math, though. So we would need to show that you have 2 sets of adjacent or connecting sides have the same distance. So you would need to find the distance of all 4 sides. You would have to find the distance of all 4 sides and then check to see if 2 of them are the same and the other 2 are the same, and make sure that those 2 are actually touching each other. So if I have this length right here is equal to this length right here, then that wouldn't really work unless it's a sideways kite. So as long as the lengths are in fact touching, then it is a kite. The next one we have is a trapezoid. The next quadrilateral. Quadrilateral again is a 4-sided shape. It's got 4 sides. The area of a trapezoid is area is equal to 1/2 times the height times base sub 1 plus the base sub 2. Because what we're really doing is taking a triangle and cutting it in half. So a trapezoid is when I cut the top of the triangle off. So then I have 2 bases now. I have the bottom base and the top base. That is what a trapezoid looks like. That's why it's very similar to that of a triangle. So the properties of a trapezoid is we have 1 set of opposite sides are parallel. Only 1 set, not 2. So with this, when we look at a trapezoid, this is normally what a trapezoid will look like. 1 set of sides are parallel. That means that only 1 set will have the markings, not all 4 sides. So to show this in the coordinate plane, we would show that 1 set of opposite sides have the same slope. So again, we're just looking for a slope. So find all 4 of your slopes, and if you have 2 slopes that are the same, see if they are touching each other or if they are across from each other, if they're opposite of each other. That's how you know if it's a trapezoid. The last one we're going to look at is called an isosceles trapezoid. So the area formula is the same. It's the area equals 1/2 times the height times base sub 1 plus base sub 2. So as a reminder of the height is from top to bottom. So anywhere from top to bottom, from base to base, would be your height. This would not be the height of a trapezoid. The height is from base to base. So on an isosceles trapezoid, we want to have isosceles goes back to two sides are the same. On an isosceles trapezoid, we will have that one set of opposite sides is, or are, parallel, but the other set of opposite sides are congruent. So the other set. So if we have this, we would have the top and bottom here. I'll say these are the parallel sides, but the other sides would be congruent to each other. So remember, the height goes from top of the base to the bottom of the base, so the parallel sides. So from the top of the parallel to the bottom of the parallel, that straight up and down would be the height. Base sub 1 would be the top, base sub 2 would be the bottom, or vice versa. So we'd add those two bases together. So to show this in a coordinate plane, we would show that one set of opposite sides have the same slope, and that the other set of opposite sides have the same distance. And these are the types of quadrilaterals that we will be dealing with. But again, we're only using slope and distance to prove that these are in fact triangles or quadrilaterals.